Stay home and watch on YouTube if you'd like. Classes are being live streamed, so there's a camera going right now, and I can't show you because otherwise I'll get like a reflection going. But it's I will post the link to the live stream every day, and then you just click on that, watch it. I can see one person watching us right now. Don't know who it is, but that's okay. There's also a chat that's active, so you can just send messages and assign and questions. One of my classes is completely remote now because they closed our building. So for my bio class, I have to do the whole class remotely now. So we'll see how it works. Things will be posted in the classroom for assignments and the like. It's going to be a very interesting period of time. I have sent away for your next booklets too. So we'll see those coming in hopefully in the next day or so. Uh-oh, that's not good. Maybe I just got a note that due to the large volume of work, we cannot guarantee that things will be completed before Friday. No, I'm just on the website for the printing. I was going to check your current print jobs and see if I might end up having to print those in the building. Okay. Let's see how we did. All right, how's everything else been going? We are pretty much, I didn't even realize how much we were done, but we are really essentially done this booklet, and we will be starting the other booklet right away. Oops. My stuff. Other class finished. So we're gonna get. Oh no, it's in production. Maybe we'll make it. So the only thing we had left to talk about was this translating word equations into balanced reactions. So I'd like to try that today, and then we will start the other booklet on acids and bases ASAP. So this will be, it's kind of putting everything together, right? Because when you're given a problem in word form, then you have to do the conversion of word into chemical formula. Then you have to do your balancing, and you can even identify the chemical reaction after you're done. So let's try one of these right now. Iron metal and sulfur powder react to produce solid iron 2 sulfide. What would that chemical reaction look like if I wrote it out in chemical notation? What would be the chemical notation for iron metal?
Fe.
Yeah, very good. So Fe. And what about sulfur powder? Yeah, you can look it up on your periodic table. It's describing an elemental sulfur. So it'd be right on the front of the table. Yeah. We don't notice anything weird, like no ides or eights. So it's probably just going to be
sulfur is S.
Yeah. So sulfur powder is just they're just describing what it would look like, but it's just S. Nothing too exciting. And then it says they react to produce solid iron sulfide. So we're going to put a little arrow for the react. And that says iron 2 sulfide. What would that formula be? FeS. And would we have 2 of them? Let's think about the charges here. We got iron 2 plus, right? Because of the 2. We have sulfide. What is the charge on sulfide? Yeah, so both of these elements, both of these ions have the same charge but opposite. So when they come together, how many of each do we need? one of each. So we're going to bring these together. We're going to say, well, look at those. Those charges are the same. So we can just get rid of them.
So yeah, wouldn't it just be FBS?
Yep. And we get FeS. And it does say that it's solid iron sulfide, so we could even put the little S if we wanted. We could iron metal suggests that it's a solid. Sulfur powder suggests that it's a solid. So we could put even those extra details that I didn't even ask for, but we could do them if we wanted. All right. Let's try the next one, and then we'll do the rest of the page by yourself. So let's try one more. So we have zinc metal and solid copper 2 sulfate. Oh, wait, what was that first reaction? What kind of reaction is it?
Double.
This one up here, what?
It's a single.
Synthesis. I did get a synthesis out there, yeah. 2 became 1. When 2 become 1, it is synthesis. All right, so let's write this one out. We got zinc metal. So what would the formula be for zinc metal?
Zn.
Zn.
Yeah.
And if metal, we could even write the solid if we want. That's all extra.
And solid copper is Cu2.
Yeah, and so notice the 2, right? We have to kind of read this all together, right? This is all one big thing. Copper 2 sulfate. So that means that we should think about it as copper 2 plus and a sulfate, which I believe is on your sheet on the back, SO4 2 minus. Does that sound right?
Yeah.
Okay, so what would the formula be for copper sulfate then, if they have the equal and opposite charge? Oh, that's what I'm showing.
Zn,
Keep losing my voice by the end of the day. I realize I'm just not using the microphone.
Would it be
Zn 2 positive.
Cu4? That's all.
Well, they are equal and opposite, right?
Yeah.
2 plus and 2 minus. So how many of each do you need?
One of each.
One of each. So we can bring them together.
So it would just be Zn.
CuSO4.
The equal and opposite charges cancel. This again says it's solid, so we put a little S. They react to produce solid zinc sulfate and copper metal. What's the charge on zinc on the back of your page?
2.
Also a 2 plus ion. So 2 plus. And sulfate we know already is SO4 2 minus. So what would the formula be? CnSO4. Just bring them together because they're equal and opposite. And then we're just gonna, and that's a solid again. And we're gonna bring that together. What's the formula for copper metal?
Cu.
So this would be a single replacement.
You got it. Single replacement. Come see me if you need help with this. If anybody needs help this afternoon, I'm much more around because my building's closed. So if you need to find me, I'm a little bit more available. I'm usually in 208. I'm only not available between 12 and 1 when I record my Bio 40S lesson. So outside of 1 o'clock, if you come to 208, I'm usually down there, and you can find me, and we can talk about stuff. Okay, let's let you try the next two. So you've got solutions of silver nitrate and sodium bromide, which are going to react to form sodium nitrate and silver bromide. When you read it, do you see the reaction in the reading? Because even just reading this chemical reaction, I notice that I have sort of silver nitrate, sodium bromide, sodium nitrate, silver bromide. What kind of reaction does that sound like?
Combustible.
There's no carbon though. No oxygen. Silver nitrate, sodium bromide. Sodium nitrate, silver bromide. It's almost, yeah, the old wife swap. Yeah, so the double replacement. We have two pairs that both get switched. Okay, I'll give you a second to work on that. If you have any questions in the chat, feel free to drop them in there. No. Rio Splendido just suspended public seating. I don't know how they got my phone number and sent me text about that. But double check, make sure we're not falling right into the building.
First one. So far, that's not what I'm You see it? There's a clock. Just we have put down. Remember the first one it says upper metal is formed as well as. So you have the zinc sulfate, but you're forgetting the copper metal. So yeah, and everything else is right.
Here.
One flesh.
Yeah, so it's like
Then it's silver. Oh, no. So it's one word.
So it's not SO3 and O3 minus.
No, here, look, it's one word.
Yeah. Yeah, that's it.
it just means that there's three oxygens. The nitrate is a chemical. One nitrogen. It's got a special name. It's also charged. Silver bromide is silver. Okay, I haven't had one that has a balancing issue yet. Just the ones that I did. Or even balancing yet.
So
And this one?
3 and 4 are 4 and 5 are balancing.
4 and 5 are balancing?
Yeah.
Okay.
But each is balancing. Like nothing to like fold.
Well, I just saw the best demo, which was this demo where they boil water and then they put a cap on it and put it upside down and put ice on top. Yeah, so if you I took a Erlenmeyer pots and they boiled water in it, put a cap in it, flip it upside down and put ice on top. And then warm it.
What's the water that you boil?
No, but then once it cools down, right? And then when you put ice on it, the ice helps it boil.
Reduces the pressure or increases the pressure?
Reduces the pressure of the gas in there, so the water is boil to fill in that pressure. It's pretty good. It's, I was like, it makes sense as soon as you figure it out, but like that first step, you're like, what?
Some flats like shadow though, if you put ice on it if it's what you want.
Yeah, I definitely need to use like higher ice or whatever. But also, just even like cold water, you get the water on. So this will be 4-8. That's the only trick. So I didn't say this, but I just- Yeah, it's unfortunately not a full amount of oxygen. It's in fact sulfate is 4 oxygens, chlorate is 3 oxygens. It's related to a higher concept that we have to play with later.
So here we have solution of what? Silver, the same. Silver,
So Muzi, we're just on the last page. There's some activities there with converting word problems into chemical reactions. This one, yeah. It would be-
We're gonna keep
Put these
up to
together.
energy.
Are these together? But now I'm just gonna throw up number 3 there because I see most people have finished it. So we have a solution of silver nitrate. So I'm gonna go to my table on the back of my periodic table. Silver is Ag, nitrate NO3. Both of them have a charge of 1. So we can just put them together like that. And then we're reacting that with sodium bromide. So that's NaMPr. Also a +1 and a -1 ion. So they match perfectly. And then they react to produce a solution of sodium nitrate and solid silver bromide. So sodium nitrate is Na, and then the nitrate partner, so I'm going to bring that NO3. Again, a +1 and a -1, so they're equally matched. And then a silver bromide, also a +1 and a -1. So they're also matched nicely. The good thing about dealing with elements that have the same ionic charge is that you can just throw them up there and they're balanced. The next one has chlorate, so watch out, is on your table on your chart as ClO3, and is potassium chlorate. This is a very exciting reaction. Potassium chlorate is an incredibly reactive compound. It is considered what is known as a strong oxidizer, which is a chemical that can break down other chemicals very easily. If you heat sodium potassium chlorate, one of the reasons it's a very strong oxidizer is it produces some solid potassium chloride, but mostly it produces oxygen gas. And so because it requires heat to do this, you end up producing a bunch of oxygen that's really hot. And if something is nearby, it will react violently. And there's a classic experiment or a classic demo that we can't really do because we don't have a good fume hood here, but it's called the Screaming Gummy Bear. And yeah, and I'll show you one. How does this work? Are we allowed to do a live stream of a video? So here we have some potassium chlorate down here. We're going to put potassium chlorate in this test tube, and we're going to heat up the test tube. So here's the potassium chlorate. It's just a white powder, like most chemicals in chemistry are. Just white powders for the most part. They're pure. So here they're scooping out some potassium chlorate. And let's get to the part that's exciting. So here they'll melt it. Once they melt it, they get a sort of a slurry that has the melted salt, and then also a lot of oxygen is trapped in here. There's a lot of pure oxygen down inside of there. And when they drop the gummy bear in, I'm going to give myself some sound here.
That is insane.
The purple color is from the potassium ions. It gets really hot. You can see the amount of smoke it produces that we can't just do that out in the open here.
I think we converted that sucker to CO2.
Yeah, and so you're left with what's left of a gummy bear down here. This is mostly carbon. So you've actually taken the sugar in the gummy bear and converted it to pure carbon. The smoke that was coming out is carbon dioxide, and there's not much else left. There's must have been some water vapor, so you lose some water vapor there. So very similar reaction to what's going on in your body when you digest sugar, except you digest sugar much slower than that. So, but that's one of the reasons we're hot. Like one of the reasons our bodies are warm is that we're digesting sugar. We're getting energy out of digesting the sugar. It's not happening as spontaneous or as crazy as fast as that, but that's the kind of energy that's stored in sugar.
Let's drop our subject in.
It doesn't like me double streaming here. Streaming is
So,
streaming.
you know, oh, look at that. That's beautiful. That was so freaking cool. I'm sure that's
That's it. Well, the gummy bear is just a source of sugar in this case. So you could actually use any source of sugar. You could put you could put a sugar packet in there, or you could put like a sugar cube. Anything that has sugar in it. Maybe the gum itself might also break down. Yeah, gummy worm, sure. Yeah, it doesn't matter what it is, but it's always fun to call it a screaming gummy bear. If you use a really tall, like the taller and longer you can get your test tube, the more scream it has. Like works like one of those like kid toys where they have like the little around one of those, or like those like what things you spin around. The longer the tube, the more sound you get, and you can make some really sort of move a swale of things. So this is that reaction. This is not quite that reaction. This is the start of that reaction. that light and fire that they get from that sugar, that is the reason you're breathing, right? You're breathing in oxygen so that your body can take the oxygen and do that to sugar molecules in your body. It's the whole reason you eat and the whole reason you breathe is to squeeze that little bits of light, or in that case, lots of light. And that's why like you can get such a sugar rush from like a piece of a high fructose corn syrup or whatever. Is you're getting a lot of energy like that energy in the form of sugars is easily broken down by your body for that light. It's that little bits of light and heat. Is there anything wrong with the way that we wrote this chemical reaction right now?
Yeah, there was a minus above the 3. No balance.
3. Yeah, there was a minus, but now I've matched it to a positive potassium. So now the charges can be balanced. But it's not balanced, that's true. What's not balanced about it? The oxygen's not balanced, yeah. So we have 2 over here, we have 3 over here. So what's the first step? We can multiply, right? So let's put a multiplier in front of one of these numbers. Do you want to put a multiplier in front of potassium chloride or in front of the KCl? In front of the oxygen, where should we put a multiplier? Multiplying by 3? On this one? Or on this one? Here? This oxygen multiplied by 3? Sure. So I now have 6 oxygens. What can I do to match that on this side?
Multiplying by 2 plus 6.
Put 2 there. We now have 2 potassiums. Yeah, so this is again that technique. Just pick one number to fix. One element, fix that element. Doesn't matter which element it is. Fix it and then move to the next one and don't look back. And if you end up coming back to that element later, that's okay. But start by fixing one inequality and then usually it'll work out. So there we go. All right, what kind of reaction is this one? This last one? Single. We have one thing breaking into 2 things. Decomposition. Yeah, so that would be a decomp. And our previous one, our silver nitrate and sodium bromide example, what kind of reaction is that? Double, yeah. Yeah. What time is it? Do we want to introduce acid bases now, or do we want to just keep working on these today? How far have you got? Do you want more time to work on these?
Can we actually do the next one?
Do the next one? Okay, let's try the next one. Oh, we could put some symbols in too. There's lots we can do with these, right? We could just keep adding more features. We forgot the symbols in this one, so we could come in and put solid. We noticed that they said solid potassium, and they made gas, so I'll put a G for gas. Okay, liquid water breaks down to produce hydrogen gas and oxygen gas. What would that one look like? H2O, arrow.
HS plus O2.
We got hydrogen gas and oxygen gas, right? Is it just H and O though? What's special about H and O for gases, for elements?
Hydrogen gas would be HS.
It'll be H2. H2. They're part of that Hofbrinkel. All of these elements are always represented by a pair. Yeah, we got a liquid, we got a gas. Is it balanced? Well, what do we need?
Two in front of the H2O.
So we need more oxygen, that's right. So we added an extra water.
So we need a 2 in front of the H as well.
Well, now we have 4 hydrogens, so we need a 2 in front of the H's. Gas. It should be an L for liquid, yeah. I always use a little like italic L kind of thing. I don't know why. I guess because L doesn't look like anything, you can just put a line. So it's supposed to be lowercase. So I always use a lowercase hand script L. All right, let's see you work on the next couple. I'm gonna come around and see how you're doing. So show me what you got. If you're having trouble, and this is a good time to ask. Matthew's around as well if you'd like to ask Matthew or Abdel for some help on those. Let's try to work on this next one. Solid mercury oxide is heated and breaks down into mercury metal and oxygen gas. Oh, this said water breaks down into these gases. So what kind of reaction is it? Decoms, yeah. Good. Just waiting to hear from more than one person. Decomposition. Even this next reaction, just listening to how it's written, solid mercury oxide is heated and breaks down into mercury metal and oxygen gas. What does that suggest? Another decomposition, right? And once you know it's a decomposition, you know that you should only have one chemical on the left and probably 2 chemicals on the right. It's decomposition.
That's right. And balance as well. Yeah, no, the balance is correct as well.
Oh, okay.
This one's correct. You just have to make sure this balance right. So yeah, also have to make sure the number of the atoms of each is the same on the left and right. So one oxygen is always going to be O2, right? Oxygen gas. So if you have 2 oxygens on the right, you need 2 oxygens on the left as well.
Something.
Because oxygen gas will always be O2.
Yes, here is two. C just one, just 1 unit. Here we have one. That's two. And so you have two units. And this is two. That's one. So this one is the same unit. Same reference. 100. Because this, look here. This one, replace 0 by 0. So just take this one. And this one becomes 0. You see? Yes, we just.
So when looking at it, it says lab 2 nitrate, right? So lab 2 is the positive charge on the metal, not the substrate.
Even just.
So nitrate has a -1 charge and the lab has a 2 plus charge. So if the 2 is up here and the -1 is up here, where is this 2 coming from? This is lead to nitrate, right? So how would you bring those two together to form that nitrate?
You see here CO2. You see CO2 plus CO2. And also CO2.
Yep.
Right here. You see this?
Yeah, so you're right, you bring those atoms down and you just put the nitrate in bracket so that that 2 applies to everything. Yep. You just crisscross the charges, right? And it's the same for that iodide as well, with that 2 plus and the I minus. So the second part is right, like you have to be that out of that has a 2 plus charge, right? And iodine has a -1. So if you're crossing lead with iodine,
Yeah, it equals each other out.
Oh, here.
this is 2 plus and -1.
So far.
Yeah, yeah, it equals each other out.
So So remember you put it, you put the crisscross, right, you bring the charges down, with the TB and two.
And the ocean, that's for the black nitrate,
Remember,
from the ocean, maybe it's from the airplane.
mixing the
Control.
and the -3. So we have
So we
against
still
the
have
crisscross
the
charges. And you have to put it like it's around and on the side. So that
Yeah,
has
to especially.
substrate of the plastic
It's
whole,
worse.
ion.
China did, they did very good job.
No, so that's what right, so the whole ion has a minus value. So the minus value comes down, just one, and not right. You just say PV, then NO3, and then subscript of 2 get comes from the positive 2 down on the right. So that's when you get the formula down on. And then you just balance it.
Yeah, that one was weird.
Come back tomorrow if you like. Review tomorrow. But as far as I know, we're going by what the province has said, which is classes till the end of the week. Yes, sir.
I don't know the balance.
That's cool. Yeah, we're not expected to until the.
Okay.
I know these
That looks good. And then you're missing the nitrate, right?
Yeah.
So let's see the two nitrate.
So,
So now,
Two nitrate. We need that,
For the eyes, right?
right?
so you put the two minuses.
means that's the,
Or twos.
doesn't see plus.
That's
Now, no, it's finished.
no, no.
So and we have to do, you have PI2 on this side, and just KI on this side. And you have one eye,
Yeah, that's true.
Just
one two eyes, so you're no two eyes, another eye to this side.
Oh, okay.
Yeah, well, we're gonna do the
And.
we're gonna say that would be additional days also.
You're on the right train of thought now.
Now, on the other side,
So
you
once you
you-
balance the eyes, your focus is on right.
Yeah,
So you balance the face and then it comes out.
Yeah, it's the same. So
Here.
keep adding.
Number two.
So the first step, like you were saying, right, is to put it two here.
So,
Yeah,
so
you have the
all
same
that.
number back.
And it affects the.
Yeah. And like,
So
like,
rebalance
which one?
this.
that one
So we have
would also be.
Yeah. You don't
Yeah.
check that. And then it's balanced. So with this one, you got really lucky because it's balanced out really good. It doesn't feel the nitrates off.
Because the nitrate, nitrate oxide.
Yeah, that's
Also-
awesome. Right.
So
When-
So if you want to,
basically,
there's
that's.
no problem there.
Because you have this substance two here, you have two nitrate ions.
Yeah.
And because you have this
I
one,
got it.
trace, you also have two nitrate ions. So it's balanced. Yep.
So it's just that BFM.
One lead.
That's not one of the nasty ones.
And now the charge.
Some of them.
So I would like it eventually to clean up the charge, not the things balance.
So solution,
It's like erasing things.
solution is.
They're not necessary anymore. So that's it. Okay.
And,
Okay.
and means.
Okay, all of these are happy on each of the
They-
chemicals. So now we look at the full reaction. Go, two ions here. So now we think about balance of chemicals. So how many KIs do we put in? So that we would have to simplify. Right? So
So
we
look,
do
minus here, and two. That means what?
So now, we look at the bottle, now we have two Ks, right? So let's look at well, now we have one, so we have, now we have two, we have three. So that's what I mean by now, one thing to fix, and then just follow it through. So we pick the iodine part, we fixed it, and then we called the date. So over here, we fixed it. And then we checked the last thing, and it'll move back and already fixed it. So
That said,
sometimes you might find that third number needs to be put in, but
Well,
us.
we're gonna have to, that's.
Sorry.
Is it two
Oh, so 2 times.
Yeah. Just
Oh,
make
okay.
6 there.
Oh, okay, that's right. So it's just like, okay. Get there.
It's kind of that there.
So this one's just self-balance.
You want to work on not the ocean box more directly.
Just remember, oxygen gas is always dynamic, right?
Yeah.
It's always open.
Also, the oxygen would have to be.
So it could be sulfur, aluminum, something else.
Yeah, so it says range, yeah, so they're talking
You,
about range.
whatever.
Yeah, but it's self-balance.
Yeah, chlorine gas. And it says it
Depends
makes
on the
it-
charge.
Yeah, because you got 2 positives,
Are you rating 6
positive
months?
3.
So they actually tell you all.
No, it changed
2
only
negatives here.
The only thing they haven't told you is
the
that.
item, this solution is.
So they're saying that big U plus F2 is this.
It's here,
So you have to be the
So they're looking for a chemical.
So remember the oxide ions
So all you have to
actually
do is
go
check
like
those, the
Oh.
electrons they have.
It looks like this. This is not harmless of the monoxide.
So this is an element here,
This charge of
this is
chlorine
a fluorine gas.
with the two negative charge of dioxide. And then this
So we're just gonna write big U
Solid,
plus F2.
Okay.
So you will have to balance it.
and aqueous potassium.
It's pretty much the charge on the metal that charge if you're gonna have to balance it out.
Yeah, so it's.
Yeah, and that was a balance. Looks like your fluorines aren't balanced, right? So how do you put it, where do you put the number to balance those fluorines? Always remember, we're gonna always put our numbers in front, right, our coefficients. So do you want more UF6s or do you wanna fix the number of F2s?
Yeah, but.
I mean, like if you put a number in front here, you can make more fluorines. So what do you put, 3?
So on this, have everything has
So
two
3
rows.
times 2 is
This
6,
is that's right.
and you got 6
And
in
then
there.
we have 5 over here. So like the first thing I did was just put 2 here.
It does say iron as well there. Notice that there's a metal there. So you have to put I and Fe there.
So you have to
If it just says the metal, then we're just
put
gonna
6
Fe.
on each side. So you actually have to put
So Fe plus chlorine
and then
gives
3
us
here.
this chemical.
And then that draws them from the heart again. So then you exchange the 4 to the 2, or the 2 for 1. This one's an example, so you have to
It should be an arrow, not
take
X.
several times.
Equals means the same, right? Whereas arrow means to change. Chlorine gas and iron, not super good. And neither of them are, chlorine gas particularly very nasty to work with. Iron chloride, could probably survive eating iron chloride. But chlorine gas, not so much. You can't breathe in chlorine gas and feel good about it. Okay. This one has been disconnected here. So.
But if you have 2 negative.
How's my stream going? Hope you're having fun at home. We're doing the lesson. Got
2 here.
0 viewers now. Okay, so we have 5 minutes left. So let's go through a couple of these, just so we have them up on the board. So solid mercury 2 oxide. So it'll be Hg 2 plus, O 2 minus. So I see they're matched. Get rid of the symbols. Is heated and breaks down to form mercury metal plus oxygen gas. And if we want to be really precise, we're going to put in our little symbols like that. Okay, Is it balanced?
No.
Nope. We need more.
Oxygen.
We need more oxygen. So we're gonna put a big old 2 there to get those 2 oxygens. So I actually liked what I saw earlier, which was kind of following the path here. The 2 means we wanted a 2 there. And now we have an imbalance of mercuries, right? So we're going to have to go and put a 2 here. So we kind of have a little daisy chain of things. Solutions of potassium iodide, which is Ki, and lead 2 nitrate. So that's Pb 2 plus and NO3 minus. So we need to balance that chemical first. So how do I balance this chemical?
Brackets and 2.
Yeah, brackets, and I need 2 of them. Okay, I'm gonna slide that over. I get an eraser and go in and fix those symbols away. And that changes into solid lead iodide, PBI. I'm going to come back to that. And aqueous potassium nitrate, which is KNO3. Okay, this one is +1 and -1, so that's okay. But this one is 2 plus and -1. So how do I balance that one? I have heard people doing brackets here, right? But that's we only have 1 element, so we don't actually have to use brackets in this case. So we're going to get rid of the bracket, but we will keep that 2. The 2 is the right idea. Okay, get rid of those. And then we are going to go for some balancing. So who should we balance first?
You have to balance the potassium.
Okay, well, potassium seems balanced so far. You're right that I'll probably end up balancing it later. But the first thing I notice is there's 2 iodines here, right? So I'm going to balance that one. Is that okay? So put a 2. Now I'm going to have to balance my potassiums because now I've suddenly made my potassiums unequal again. So I'm going to take my potassiums here, put a 2. And now I'm going to check out my nitrates. I get 2 nitrates and 2 nitrates. And I can treat that all as one thing because it stayed the same on both sides. That's the one thing that didn't change is the nitrate. So we can just kind of look at it as one chemical. That's the same here and the same here. And I got 2 of them here, and I've got 2 of them here. So that's also balanced. All right, I think that's it for today. Hopefully you can get some practice tonight. Tomorrow we would like to start the next booklet.
We have tomorrow.
Yeah, all the way till Friday.